about the uh, data types. The two data types that we discussed yesterday, like three data types, that was integer, character, and a bit. Okay. So size of bit is a single bit. The size of integer is 16 bit, and the character is 8 bit long. Then there are signed and unsigned variants. Okay, there are no signed and unsigned variants in the bit operation. Okay, so like bit is a single thing. There cannot be a signed and unsigned operation in the case of that. That's kind of binary thing. That's why. So now you are very well aware about the data types in embedded C. Basically, whenever we discuss this C programming in 8051, at that time that C programming is known as embedded C because it is somewhat different than your regular C programming. Like you have some extra keywords. For an example, SFR is the extra keyword, SBIT is the extra keyword. There is one more keyword that are only related to 8051, only related to this subject. Okay. You will never see that kind of keywords in general purpose C language. Okay, the SFR, SBIT, and interrupt are the three. We didn't have touched the interrupt yet, but we'll come to that at later point. So now you know how to create a program. Like at least you know how to create a program which can toggle LED continuously with some time delay. And we also know like how by changing the data type, how you can manage the time delays. Okay, so there can be two questions can be formulated from this program that we have done in last lecture, that write a C program to toggle LED continuously. Okay, pin would be given to you, like for an example, pin P1.2 or P1.3, and then you have to write a program. But that program can have two variants. Okay, so the in first variant, what you can be asked is write a C program. Write the question. Write C program to toggle LED connected to pin P1.5 with short delay. So this can be one question, and in other question the whole question will be same. Instead of short, what I'll use is long delay. So what's the difference in between these two programs? So short delay means you are going to use a character, okay, for formulating your for loop. And in case of your long delay, okay, this one is for short, you are going to use a character, and then you are going to use a for loop. And in case of long, what you are going to use is integer, and uh, your I will be ranging from somewhere around 10,000 to 15,000 or 50,000, not 15,000. And here your I will be ranging from like 150 to 250 would be great. Okay, so always stick to one number. Like whenever a short delay is asked, always go for 250. And whenever a long delay is asked, always go for 50,000. Then nothing will trouble you. Okay, so the only change in the program will be here. If it's short, then you can go here with 250 like this, and if it's long, then you have to write integer, and here you can have 50,000. Otherwise the whole program will remain same. And the third change will be here depending on the pin. Okay, for example, here it is given P1.5, but if it's P2.3, what would be the number here? If your pin is instead of P1.5, if I have given P2.3, what would be the number? It is very easy. Even I have given you a trick how to do that. So I expect an answer from you. Vatsal will answer. Rule number 19. Vatsal, please unmute yourself.
Yes,
and
sir.
Yeah, what if I want to like program this question, write a C program to toggle LED connected to pin P2.3 instead of P1.5, I want P2.3 to be toggle. So what would be the changes in this program? That's the question. The program is written over here, but what would be the changes? Even the change will be here. I know that. Even you know that. But what will be the change over here? What will change? Okay, anyone who knows the answer, please raise your hand. Quickly raise your hand if you know the answer. If you believe you know the answer, whether it be correct or not like it's wrong, nothing to worry. If you try to attempt the questions, I'll be happy. Soumya, can you answer? Okay. See, again, I'm repeating this same thing. Okay. You have total 4 ports. You have 4 ports named as, let's say, P0, P1, P2, and P3. There are only these 4 ports. Now, from this 4 port, on each port you have pins, or you can say resistor. Like, what's the difference between that two? The difference is huge. The port are basically resistors. These are actually your resistors. And then with this resistor, your pins are connected. How it is connected, we are going to see that in detail, but this is the connection between the two. So whenever I say P0.1 pin, okay, suppose I say P0.1 pin, or I say port 0, okay, send output to port 0, send output to port 0. If I ask you like that thing, or if I ask to toggle something over here, in both the cases, port 0 is part, okay. So you must know how to handle these two questions. These two are different questions. In this, you are going to use SFR, okay, because you are being asked to do something on port 0 as a whole, and here you are only asked to do something on part of port 0. Which part? P0.1. Point 1 is the part, okay. So how many parts are there in port 0? There are 8 parts, you can see, or I can say there are 8 bits, okay. So port 0 looks like this. There are 8 bits on port 0. The bits are named as P0.0, P0.1, 2, 3, 4, 5, 6, and 7. Now if someone asks you to do something over here, what you are supposed to do? That's the question. So it's very easy. Again, I am repeating. First, you must know whether you want to use, you have to use S-bit or SFR. That's the first question. So suppose you want S-bit to be used. So whenever you decide to use S-bit, at that time there should be something with 0.1 or point with something that should be there. Okay. So what you'll do, you'll write S-bit. Then you'll give a unique name. Let us say LED, and then you will supposed to write address. So here it is P0.1. So P0.1 is here. Okay. So what should you know now? You should know two things. What's the address of port 0? And what should I do with 0.1? That are the two questions. So if you know address of port 0, okay, so let's write the address over here. The address is at 0x80, and the next one is 0x90, P2 on 0xa0, and P3 on 0xp0. Okay, so you know these addresses now. So I know port 0 is on 80. Okay. So what you have to do, whatever is the point afterwards, replace that point afterward with this 0. So what I'm going to do, I'm going to remove this and I'm going to replace it with 1. So my number is 0x81. Same way, if I have P2.5, what I'm going to do, P2 is 90. Okay, so I'm going to write 90. What I do with 0, I'll replace it with whatever number is represented after point. So it is 95. What you have to do, you have to write 95. Same way here in this question, what is asked? It is asked P1.5. So what you are going to do? You are going to write P1 is 90. Sorry, this one is wrong. It's P2. So you have to write A0, and instead of 0, you are going to write 7. The number will become A5. For P1.5, what it will become? It will become 95. For P2.3, it will become A3. P3.2, it will become B2. Is there any difficulty now? Okay. A question to roll number 34. What if I have P1.7? What should the number? What should be the number? Question to roll
97.
97. Okay. So 97 is the correct answer. But how you are going to write it? You are going to write it in hexadecimal. That means you are going to follow it by 0x97. That's the only
0
difference.
into 97.
Okay. So this is how you are going to write if a pin or a bit is being asked. But what if as a whole port you have to send the output? Okay, for an example, in this question, send output to port 0. So port 0 is like bunch of bits. Okay, this is my port 0. So I have to send some data in all of these bits. So here what I'm going to use, I'm going to use SFR instead of SBIT. So along with SBIT you will see this kind of things. Point something, then you are going to use SBIT. But if only the name of register is given, in that case you are going to use SFR. Okay, and then you are going to give name. Port 0 is P0 obviously, and what you are going to do, P0 directly write this number. Okay, not like this, it should be like 0x80. Okay, same way if port 2 is asked, what you are going to do, you are going to write SFR P1 P2 is equal to 0x which number, A0. So this 4 number are only that you have to like remember. This is only part of the program which you have to remember. Okay. Otherwise you can write the numbers in this way. So that's the question that can be asked. Okay, now let's see one more program. The question is, write C program to send let us say to send 0x55 and 0xAA one by one to port 2 continuously with short delay. So this is the question. Okay, which are the information that I have been given? The first and the most important information is this one, port 2. What I have to do, I have to send something on port 2. So if I have to send something on port 2, what I'm going to do, I'm going to use port 2 as an output port. Okay, if I'm sending something to any of the port or any of the register, that means I want to use my port as an output port. Okay, because I can use the port as input port as well, and we are going towards that. That's why I've given this information. So I'm going to use this port as an output port. That's the important information. So you have to give the number, like you have to let the 8051 know you want to do something with port 2. So how to do that? We know that the port 2 is like whole thing. So I'm going to use it with SFR P2 is equal to 0x. Which number? Anyone can answer. Which number?
A0.
A0. Okay, correct. A0 is the number. So I'm going to write SFR P2 is equal to 0x A0. Then what's next? Next, I have been asked to do some task continuously with some short delay. So the important task is to generate a short delay. To produce a short delay, I know I can use integer, but I'll keep that part as of now. So I'll keep some space and I'll start my void main here. See, this is how you are going to build a program. Now, is there any task that has to be performed only once? Like this two has to be done one by one and continuation. Okay, so this is not the task that I should be doing once. So I'll skip that. So there is no task given over here that should be performed only once. There is no task like that. So I can directly start with my while one. This is how I create infinite loop. Then what should I do? Then I've been asked to send data 55 and AA with some delay in between. Okay, so let us send first the first number. So how to send that? Very simple. Write to port 2. So I'm going to write it to port 2 by writing P2 is equal to 0x55. Now this instruction here and this instruction here are totally different. Okay, what I'm doing here, I'm giving a label to address. So this is my address actually, and here I'm actually assigning the data to P2. Assigning the data. Okay, this is assigning operator. This operator. Equal to is known as assignment operator. Whenever I use equal at that time, your left hand side, this is my LHS, would be transferred to your RHS. That's how it works. Okay, so whatever is on left hand side would be transferred to the right hand side. It would be saved in your this right hand side. That's the thing. So I have sent my first data 55. Then what I should do? As soon as I send 55, I have to wait for some time because it can be asked like do this task with some delay in between. So I should write a short delay. Sorry. So I should write a delay loop. How to write a delay? We know that we are going to use a for loop, whether it's a short delay or long delay, short delay. So I know I should stick with I250. So I'll write I less than 250, I plus plus. Whenever you are forming delay, this is the only thing that you are going to write. A for loop followed by a blank body. So this is my short delay. Then what I have to do? I have to assign the second number, that's 0AA. So what I'm going to write P2 is equal to 0xAA, and then you can write for again. Now I have to again do a for loop. Why? See, if I don't do this, what will happen? A program will come here, it will send 55, it will wait for some time, and then it will send AA. Then after sending AA, where it will go back? It will go back here on the first line. So immediately after sending AA, it will again send 55. So you won't be able to see that. So whenever you are sending two different things on your port with one after each other at that time, make sure after each instruction you have your delay. So here again I am going to write a delay for I equal to 0, I less than 250, I plus plus, and then a blank loop over here. I'll complete my body, I complete my while. Now anything that has to be written, yeah, I have used one variable I over here, one variable I over here. Now I can do this. Can I use the same I over here and here? Yes, because what will happen once you enter here, your for loop will start executing. At that time, I will become 0. At the end, your I will become like continuous operation will be added, but it won't exit this loop until your I become 250. And so once it exists here, are you going to use I again? Like, is I useful for any of the tasks? No, I is not full useful. So again, I can use I over here. Okay. But if there is some variable that can be used in future, in that case, you should take care that you do not use that same variable in other for loop. Otherwise, what will happen? Right now, I is 250. As soon as you enter here, again your I will become 0. Okay, and again your whole task will be executed. So keep that in mind, like how many times you are using a same variable. So this is my program, but the thing remaining is I should be declaring this variable I. So we see that number, that's 250. So I can use character signed operation or unsigned. So obviously I'm going to use unsigned operation because sign is not at all important to me right now. So unsigned character 5. So this is the program. This is the whole program. So let's quickly execute this program. So what I have to do is SFR P2 is equal to 0x 0. It's a P2, and here what I'll have is 250 as a delay. Here I have one more line. That line is P2 is equal to 0x88, and this is the program. Now let's try to execute this program. So I'll press F7 to build the target. Okay, so 0 error 0 1, and I'm going to use Control F5 to start the duplication. Now, whenever you use this kind of port, at that time you won't be able to see this on logical analyzer. Okay, that's the first point. So, what we can do on logical analyzer is only you can observe bits or pins, and here no pins is declared, so I cannot write P2.7, and it will won't show P2.7. Okay, so rather than that, we can observe output over here. So right now you can see this is parallel port 1. I don't know that which port I need to see the output. I need port 2. So how to get port 2? Go to your debugging session, peripherals, go to input output port and select port 2. Okay. So here is my port 2 and I'm going to run this program. So you can see here continuously it is sending AN55. Okay. Now let us try to include that over here. So I can set it up, use this, and I can write P2. Okay. So as soon as you do that, you will get P2. But why I do not prefer that is the thing. Let me zoom all. Okay. Now you can see here your P2 range of P2 is 0 to 255. Okay. Why? Because P2 is 8-bit register, and in terms of decimal, it is like 0 to 255. So now you can see this. The duration of this one and duration of the other one is different, but what's important is this number. Okay, so here where I reach this line is actually my 55. Okay, but in terms of decimal it would be a different number. Let me show it to you. See, this red line is 82 and this blue line is 170. Okay, you can see this 170 over here. So the blue line is 170 and the red line is somewhere around 80. So basically what we are getting here 86 or 85, something like that. So what we are getting here is basically just conversion of your 55 to decimal, but this is not the correct way to look at the port. Okay, that's the wrong way, but anyhow it will work as of now. You can observe this thing. Otherwise I do not prefer this method. I only prefer this method, and the time delay is not important over here, so we are not going into we are not going to watch the time delay. But this is how you do a program. Sorry, here we should be using character. Okay, so this is the output. You can see continuously varying output. So that is AN55. Okay. The same question can be asked like uh, almost same, not same, but almost same question can be asked like continuously toggle port 2. Okay. What is the question? Instead of sending this number, continuously toggle port 2. So what you can do, you can take some number on port 2 one time. Okay. So in that case, what I'll do here, I'll write one line of the code, let us say 0x55, and then I am continuously toggling it. Okay, so I'll use an invert command instead of this line. Okay, so how the program look like if the question is like that would be this. Instead of this line, what I'll do is P2 You can do it with any number, okay, no issue in that. The port should toggle on it. So you can send P2 is equal to, even you can start with like all zeros. In that case also it will toggle. So that's 0x00 and I can run this code. Build the target. Again, how to build target? Go to project, build target, go to your debugging session, start debugging. Okay, and this is the point where I'm going to run this code. Okay, so you can see now continuously 0 to FF, 0 to FF. Okay, so it is like all zeros, then all are inverted. Okay, so all become ones. Like ones complement we are sending. This is kind of ones complement command. So this is the output. Okay, and you can do it with any number. Like for an example, if I send instead of 0 0, if I send 55 over here, I get the total again, no issue. Okay, but now the amplitude has been changed. That's the only thing. So this is how you can toggle. You can see this toggling continuously. But read the question once and then try to answer. Okay, like if it is asked like send A and 55, then you cannot use this. This is wrong program in that case. What you would be doing is this. Now same way, if toggling question is asked, you have to use this line of code, inverting like one's complement. Okay, that's the thing. That's how you are going to program. Now this is whatever we have done with this port is with the like a all were outputs. Now I want to use my port as an input. Before going there, I ask you two questions, and that's homework. You have to complete submit it tomorrow. I'll ask someone. So what's the question? Question is this. Rather than writing it like this, what I'll do, I'll directly post it in comment section. Write a C program to send number 0 to 9 continuously to port 1 with large time delay. So this is the program. Write a C program to send number 0 to 9 continuously to port 1 with a large time delay in between. That's the question, and I'm posting this question. I expect the answer from all of you, and we'll discuss the answer in your laboratory session. So keep remind me that in laboratory session we have to perform this experiment. Okay, this is a bit complex experiment because you are sending 10 numbers with a large delay in between all the numbers. So we'll be discussing this thing in your lab sessions. Probably we have lab on Thursday. So I'll answer this question on Thursday, and I'll ask you for the answers on Thursday as well. Like no answers will be asked for tomorrow, but we'll see that in Thursday. So be prepared by Thursday with the answer of this question. Okay. One more question I'll give you. Okay, that would be on later on. I'll give this question later on once we get the input. Okay, so now the new thing is how to get. So we know how to get the output on the port, but how to get the input to the port? Like, what if I have a switch connected? What if I have this kind of arrangement? This is my 8051. This is my 8051. I have a switch over here. Okay, let us say this is a push button, and let us say this is P1.2 pin. Okay, so this is pin number P1.2. P1.2 is connected to a switch. Now here I should have connected resistor. This is my plus 5 volt, and on this side I have my ground. So what will happen if I press this button? What will happen? What I'll get here? If I press this button, what I'll get here? Plus 5 or 0? Now this is physics electrical, okay? I am not going to explain this like why we get something over here, but what we'll get here, that's important. A push button is connected, a plus 5 volt source is connected on one side, and on the other side I have ground. If I press the push button, what I'll get on the P1.2? Sorry?
5 volt.
Plus 5 volt, okay. Anyone else? Ujay,
Not 5 volt.
sorry?
Not all the 5 volts will be there.
Not all 5 volts, okay. Anyone who says like sir ground મળશે sir 0 volt મળશે નહીં મળે. Okay, let me give a more information. This thing, this resistor is, let us say, 1 kilo. Manish, can you answer this now? Like how many voltages I'll get? I have a 1 kilo ohm resistor, a 5 volt source, and a ground. What will happen? If you cannot answer this question, you should study your KCL and KVL one more time. Okay, do you want my opinion what I'll get? I'll get you the answer and you have to prove it, like why we get 0. So when I push the push button, I'll get a ground. Okay, or I can say a 0 volt or a reference volt. That's what I'll get. But why I will get a 0 over there? That's the question now. Okay, what if I have only this connection? Like I have plus 5 volt over here, plus 5 volt. I have one resistor, I have a ground over here. What would be the current flowing through this resistor if this is a 1 kilo ohm resistor? What would be the current? Quickly, let me know the current.
0.
Plus 5 volt source is there, a resistor is there, a ground is there. 1 kilo ohm is the resistance. What is the current that I'll get here? Do you know KVL or KCL? Okay, let me represent it in one more better way. See, this is positive, this is negative. I have one resistor like this, I have a closed circuit like this. This is plus 5, this is 1 kilo ohm resistor, and this is 5 volt battery. What is the current that I'll get? This is 1K resistor and 5 volt battery. What is the current I'll get?
1 milliampere.
How much?
1 into 10 raised to minus 3 ampere.
1 into 10 raised to minus. How you get this thing?
Sir, sorry, 1 upon 5.
Okay, that's the correct answer. It would be like 0.2 milliampere.
Yes.
Okay, so that's the answer, 0.2 milliampere. So how we get this? V is equal to IR. I want my I, so I'll get V by R. But if, what is V here? V is basically potential difference. So what is the potential difference over here? So potential difference over here is 5 minus 0 divided by resistance 1 kilo ohm. So again you'll get same answer, that's 0.2 milliampere, and that same logic apply over here. So I'll get 0.2 milliampere over here. So if you calculate logically this point, what's the potential at this point? See, there is no resistance in between this ground and this thing. So although current will flow from here, but there is no resistance, so there is no voltage drop appearing over here. That means this point is at ground level only. So if I press this button, what will happen? The whole current will go from here to here, because this is ground. Okay, and that what you will see at this end is only a ground potential, and that's zero basically. Because if I press this button, all this line is connected directly to the ground, no resistance in between. If there is a resistance in between, that then might be some different scenario, but there is no resistance, so I'll get a zero. Clear? Agree?
Yes, sir.
Yes, sir.
Correct. So this is the scenario. Okay, this is very basic, and you should be knowing this. Nothing to worry. Keep this in mind. We'll come back to this point somewhere later on. Like why I always select it always happens like this. There is a reason to that because there is an internal resistance over there. But this is the scenario. As of now, this is correct. So the scenario is like this. You have your let me draw the figure again, just a moment. Let me do this part. So I have this kind of scenario, a push button with a resistor over here and a ground on one side. This is plus 5 volt. Okay, so now I want to write a program because I have some other arrangement on the other side. Let us say on P2.3 I have one more arrangement like this. So I want to turn on this LED. This is LED. So whenever a push button is pressed, I have to turn on the LED. Otherwise, I will have to turn off the LED. I have to do a program like that. Okay. Whenever a push button is pressed, you should turn on the LED. And whenever it is depressed or there's a normal condition in that time, you have to turn off the LED. So as soon as I press button, I should turn on the LED. Like LED should be turned on when I push the button. That's the thing that you are supposed to do. So how to do that? So to do that, first you should be knowing like how to get the input from this pin, because whatever we have done up to this point was only output. So we know that if I write something in register of port, that will automatically get it to your port pin. That will be automatic, like automatic output will be there. So if you want to something on your port pin, what you are doing, you just throw it to your resistor and your resistor will take care. Why? Because it is a special function resistor. Now what I want is the opposite scenario. I have a pin. On pin I am getting something, either it might be 0 or 1, and I want to read that whether it's a 0 or 1. Okay, so how to do that? So that's all together a new question. So first of all, the first task that you should be doing is configure your port or your port pin. Okay, be it a port or port pin, it applies on both. Configure your port or port pin, this is your port or port pin, as an input port or pin. So the first thing that you should be doing while handling this kind of question is you should configure your port as an input configuration. Like you should be telling 8051 that I am going to use you as an input. That's the first thing. Okay, how to do that? So to do that, by writing 1 or 0xff, okay, on your port pin or your port. How to read this? If you write port, then you write ff. Okay? If you use pin, then you write 1 1. So by writing 1 or 0xff on your port pin or your port, you can configure your pin or your port as an input pin or port. That's the thing. Okay. So to configure your port pin or port as an input port, you should be sending either 1 or 0xXF. FF when we are using a port, or a 1 when we are using port pin. So this is a port pin or port. Is this a port pin or a port? P1.0, is it a port pin or a port? Come on, yeah. I at least expect this answer from you. Very easy. From the first lecture, I am telling you that port is made up of 8 bits or 8 pins, you can say. In this case, actually it is 8 pins. Is it 8 pin or single pin? It's a single pin. That means this is a port pin. It is a part of port. Okay, there are 8 pins in each port. Each pin, like there are 8 pins in each port, and also you can use each individual pin as a like port pin. Okay, so there are 8 pins. Okay, which are that 8 pins? It will start from P1.0, it will end at P1.7. If you want to see that, let me show it to you. 8051 in diagram. See, these are the pins. These are the port pins. Okay, you will see n number of port. P0.0, 1, 2, 3, 4, 5, 6, 7. Even I have showed you that on hardware. If you do not present during your experiment 1 or practical session 1, you should be watching that video one more time. Okay, which video? Of lab session 1. I have already uploaded that video on this seems like no videos will be uploaded to YouTube because we have to show it on your stream. So what I have done is this: go here on this links. This two links are there. Okay. On one link you'll find all the videos related to your lab session, and on the other you will be getting all the lectures. Okay, just click on this. As soon as you click on this, it will redirect to your Chrome or somewhere. Okay, so this will require sign in. Okay, so just sign in that. So as soon as you sign in, you'll see these videos. But which ID you are going to use? You are going to use Teams ID. So these are all the videos. Okay, even along with this lecture number, I have given the information of the lecture, like what's inside this lecture, what will get. Okay, so all the lectures are uploaded over here. So refer this. Same way, the other link is for your lab videos. So kindly refer this if you have not done that. Otherwise you'll be in trouble. Okay, I won't be in trouble. Let's open the same link. Yeah, okay, this is the experiments. So lab 1 and lab 2, all videos are there. Okay, so what I have done in lab 1, what I have done in lab 2, you can find it over here. Okay, so P1 and P2 is basically the same, like the same lab, but with 2 sessions. So 2 different videos are there. I haven't time for merging that. So please refer this video if you haven't be present, like you want like you won't be able to present in that lab. So please attain that or go through it once, then your concept will be clear about so many things. So I have a port pin right now. Okay, here I have a port pin P1.0, and here I have, so basically I'm going to have 2 pins, P1.0 and P2.0. So what I have to do is I have to label 2 pins first, and 2 pins will be labeled separately. So let us say first LED, S-bit LED is equal to 0x, which number? So LED is connected to P2.3. That means I can give it number P2 is B or A, and 3. And my switch is on P1.0. So my let us say push button PB is on 0x. See, now I am not using the email ID. Okay, why? Because I'm having a push button, so I should name it in a way that I can remember easily. So P1.0 is connected to push button, so I will name PB equal to 0x. Which number I'm going to get? P1.0, so it will be 90. Then what next? Next, I should be starting my main loop, and here I should be done a task that are being performed once. Now input perform, like configure as input? Should you be doing it once or after, like now and then? Configure something as input. Should it be done once, or it should be like configuration or any settings has to be done once, or it has to be done multiple times?
Multiple times.
Okay. See, generally, what happens whenever you have some configuration, once you send that configuration to someone, that thing will remember, probably that will remember that's a configuration. For example, for an example, where should I get that example? Okay, let's talk about real life example. So, for an example, you are setting up an alarm in your mobile phone. So you just configure it once, and then if you select a repeat mode, okay, so that's also a part of configuration, whether you want it to be repeated or not. So if I select a repeat mode on my configuration, do you have to set it regularly? No. Configuration is the task that has to be done kind of once or twice or thrice, but that twice or thrice depends on what? Depends on the other parameters. For an example, my alarm regularly wakes me up at 7, but if tomorrow is holiday and I want it to be lit at 8, at that time I have to reconfigure it. Okay, that's the point where I'm going to reconfigure. Otherwise, for all other days, I'm going to have the same task. So generally, the configuration is like you have to do it once, but sometimes depending on the scenario, it may be done twice or thrice, or it may be repeated. We'll see that kind of example where we are continuously repeating the configuration. But as of now, as this diagram is implemented on hardware, like this connection would be in hardware. So is anyone going to change the hardware? No one is going to change hardware. That means P1.0 is always be an input pin, and P2.3 is always going to be output pin. Whenever you have LED, this is my output, this is my output device. I can see something over here, I can send something over here. Like how I'm going to send? If I press button, it will send 0. If I depress the button, it will send 1. Okay, now 1 is not visible. Okay, oh, you might argue that, sir, 1 can't have, but it is 1. Just take it as it is now, and I'll explain you why 1 is there, but later on. So I can do that kind of thing. So configuration is the task that has to be done once. Generally most of the time, 80 to 90% time, configuration are only be done once. So I am going to configure my port pin P0 P1.0 as input pin. Why? Because I know there is a switch. So I have to configure this pin as input pin, this pin P1.0, because this is my input pin. So we know what is the name of that pin. Sorry, what is the name? Name is PB. So what I'm going to write? I'm going to write PB is equal to 1. Now, as soon as you do this, as soon as you write PB equal to 1, it will become your input pin. Now you can read that status of pin. Now you can read it. How to read it? I'm going to explain it. Okay. So let's go inside while one now. Now what I'm going to do? I'm going to continuously monitor this. What is the status of this? So how to monitor it? To monitor it, you have to read it. Okay, you have to read. So how to read it? So whenever you want to read some pin or some port, write it on LHS side. So if I write equal to PB, then it will read it. Okay. Someone will get the value whatever is on that PB. So if you write equal to PB, then you are going to read that status of that pin, and you will be assigning it to somewhere. Okay, where? So temporary, just to make you understand, I am directly writing LED. This is just temporary. Okay, this is not the correct program. This is not you write a program. I'm going to modify this program lot in like lot of modifications will be there, and we'll be discussing that modification tomorrow. But time being, just to explain this and just to have a little bit insight, I'm doing it like this. Okay, so if PB is 0, LED will be turned off. If PB is 1, LED will be turned on. Okay, Now, inverted operation will be there, I agree, but let's see this. So this is my whole program. So whenever you write your PB on your left hand side, at that time, the status of this PB will be read and it will be sent to LED. So let's see the program, whether it's working as our expectation or not. So I'm going to quickly type the program. Split LED is equal to 0x90. I have E, which has the number 83 is LED and 90. 83 is the LED and PB is 0x90. So this number are just like assumptive. You can change it at any point of time, no issue. Now I am going to configure uh, the PB as an input by writing PB is equal to 1. And I am going to have my while 1. And I'll toggle, not toggle, I'll read the status of PB by writing equal to PB. Okay, so if your PB is on, sorry, which side is this? This is our right hand side, okay, not left hand side. Just stop me whenever I am wrong, like I was wrong there. This is right hand side, not left hand side. This is your right. So whenever you write something on right hand side, it would be read into left hand side. That's the scenario. So whenever I write equal to PB, at that time I am reading the status of pin and I am going to prove it. Okay. So F7, Control F5. Now what I am doing? So I am doing read and write operation at the same time. Okay. Which port I am reading? I am reading 90. That's mean this is port 0. So configure the port 0 and port 1 both. Sorry, port 1 and port 2. So this is my port 1. This 90 is on port 1. Okay, which is 90 exactly. So pin 90 is this one. This is 90, 91, 2, 3, 4, 5, 6 and 7. So this is my 90. I know this. This is this one. Okay, this one is 90. So I'm going to send the input from this pin. Okay, the magic 1 0. That 1 0 will be sent from here. And it will be whatever is the status would be read by here, this line, and LED will get the value and LED will toggle accordingly. Okay? So see, I am running this code right now. It is continuously running. Okay, and see what happens as soon as I do this. See, immediately this LED goes off. Okay? Again, I'll turn on. And I'll turn off. Then I'll turn on. So what it is doing? It is reading the status of this pin. Okay. As soon as I make it 0, what will happen? The PB becomes 0. Okay. Though this PB is 1. So that two are different. This is this resistor and this is the pins. So I'm sending 0 at the pins. Okay. I'm not sending it to port, but I am sending it to pin. How I am sending it? By hardware. There is a hardware. So whenever you become like you send 1 and 0 through the hardware at pin, at that time it will read that pin because we have written LED equal to PB. So whatever is the pin, it will be read by like the values will be assigned to LED. So right now it is 0. So 0 is assigned to LED. So LED is what? LED is a right now A3. So there is a resistor. So I am sending it to resistor uh, of port 2, bit number 3. So it becomes 0. As soon as it becomes 0, along with that, your pin of your port goes off. Okay. So actually when I do this PB equal to LED, I am reading this and I am writing that to here. And as this becomes 0, as soon as this becomes 0, that's the scenario. Okay. If it becomes 1, the pin becomes 1. Now how these two lines are different, we'll see in the next lecture, like what's the difference between that two lines, although it looks same. Okay, so this is the program and this is the proof. We are going to do this on the hardware kit so you understand it better, but as of now we'll stop here. This is not the correct program, so do not write this program. I'm going to modify a lot of things in the program in next lecture. Okay, but we'll stop here for the today's session. If you have any questions, then you can ask. One more thing, I can set up LED over here. Okay, I am deleting this and I am adding LED. See, now I am running this code, and whenever you send a signal, you'll see LED is going on and off. Okay. See, as soon as let it 0, it will be 0. As soon as we get okay. Now this signals would be uneven in your size. Okay, this is C, uneven, because this time is in my hand now. This is how you program your 8051 input. The most important line of this today's lecture is this line: configure your port or port pin as an input pin or port by writing 1 or FF on your port pin or your port. So if you write 1 or FF in your port or port pin, in that case you can make it as an input port or port pin. Here we'll stop here. If you have any question, you can ask.